Good evening, ma'am.
Good evening.
Good evening, ma'am. Good evening, ma'am. Good evening, ma'am.
Good evening. So, students, good evening to all of you. I have yesterday, I was told that you people require some time to do that assignment which is being sent to you on cloud computing. So maybe we will keep that assignment on the next session, which is on 20th of this month, 20, which is next, not the coming Saturday, but the next Saturday. Okay. So today what I will do is I will focus little bit again on one of the AI tool, and then the next. So the session will be divided into two parts. One part is where we will be discussing about the AI in AWS, and the second part we will go about discussing about AI in security. Okay, so these two things we are going to discuss today. Okay. Okay, so Vaishali computer is ready with the assignment. Okay, you can go ahead and you can show it. Vaishali computers, if you are ready, you can go ahead and you can show that.
Okay, then okay, ma'am. Good evening, ma'am. Are you unable?
Yeah, it is visible.
Good evening, ma'am. Myself, Kailana, from Vaishali Computers, Bellary. Today I'm going to explain about the EC2 static web page and load balancer. EC2 static web page, EC2 instances is a virtual service in Amazon Elastic Compute Cloud for running applications on the Amazon Web Services. Here in instances, we have to choose like instances in HTML file. Here I have taken EC2 instance 1 and EC2 instance 2, EC2 instance 3, EC2 instance 4. If I click on instances, here we get a name as EC2 instance static web page hosting. If I click on its name, here I get a static web page hosting as public IPv4 address. If I click on open address,
Okay.
which has stored in HTML file, it shows the result here. Next topic.
Yeah, I think they got stuck.
Next topic is load balancer.
Okay.
Load balancing is a method of distributing network traffic equally across a pool of resources that support an application. Here, if we scroll down, we get the load balancing option. Here in load balancers, I have created a target groups like the EC2 instance 1, EC2 instance 2, EC2 instance 1, EC2 instance 2. If I click on load balancer, I get the name as EX3 load balancer. DNS name is EX3 load balancer. If I copy this and paste in a new tab, Here, if it shows a list EC2 instance code. If I go on refresh, it will changes to the EC2 instance three, EC2 instance two. Within a fraction of second, it will be changing. Next topic will be continued by my friend Swapna. Good evening, ma'am. Myself, Swapna sir, I'm Ravi Shankar. Today, I'm here to explain something about GitHub. GitHub is a code hosting platform for version control and collaboration. First, here we have to go to the instance, and I have created instance and EC with the name EC2 instance GitHub, and go to the account GitHub account. As you can see that HECSF is login account, and this is a repository for the name is there. And here I added the index.html file. If I again go to the management EC2 management console, here you have to click this EC2 instant GitHub, and if I click this open address name, see this is what I have stored in the index.html file. That is hello world. I am coming from GitHub. This is from the GitHub. And next I am explaining about S3. That is simple storage service, which we can protect and which we can store the data. In S3 bucket, here I can see that Swapna S3 name, that is bucket, my bucket name, R created. In my bucket. If I click this Swapna S3 name, go to this properties, and I granted all the public access here, and I have uploaded this index.html file and error.html file. If I scroll down like this, then last you can see the website name, Swapna. If I click this,
Screen is not changing, it's still the same. See?
now ma'am.
Yeah.
Here. Now, this is my bucket name, that is Swapna, which I created. Bucket name Swapna SD. If I click this, I go to the properties, and if you scroll down, at last you can see a website link. So in this, which I uploaded the index.html file and error.html file. Click this link, and here it shows the index.html file what I stored. If I click this stop button, it says oof, oof, oof. And if I click this cat button, it shows meow meow meow. Or if I access any file which is not stored in the S3 bucket, it shows oops, which are stored in the error.html file. Thank you, ma'am.
But you know what? This particular thing, a Shali computer was shown to me in the last batch also. So if you are using, and are they trying to do the same exercise, or which is been stored initially by the last batch? The same thing. I remember it very clearly for AWS
We take the
assignment.
from the last batch month.
So the last batch you have not done anything, na? That means last batch, whatever was created, you just are showing me that only.
No, we done, but we taken some guidance from the last batch.
Okay, because see, the purpose is not about showing me something. The purpose is about learning. That's the main objective that you should know. Because today, okay, if you complete, then I will continue. Yeah, continue.
That's it, ma'am. We completed.
Hmm. So you have shown me S3 and a web page, static web page also. Very good, very nice. Nicely done. Um, so any other center?
Thank you, ma'am.
Okay, so anybody who's from Kionix, office today should know that Vaishali Computers have already done. They've done a good job. Okay.
Okay, ma'am. We noted, ma'am.
Yeah, because other people I think will do it in the next session. Okay. So remember, I have given them some exercises on the page like load balancer and static web page and all. Let them show
Okay.
all, to me, but let them not repeat. You can just tell because this was the last time also I saw the same thing, what
Yeah.
I'm seeing here. Okay. So they should not take the same example and do it.
I
They
will
should
inform.
new one and show me.
Same assignment.
Yeah. Okay, fine. Very good. Very nice. You presented also very well. Both the girls have done a good job. What is your name, both the girls?
Swapna, ma'am. My name is Swapna.
And
Myself,
your name
Chandana.
is Chandana. Okay, next time when anybody is presenting, please tell your name. Also tell from what is your last qualification or what you are doing. That also you talk a little bit. Okay. So Sapna, what are you doing?
Come now I'm doing come. I completed become.
And so you are interested in cloud computing, or what course have you taken?
SAP course, ma'am.
Cloud computing,
SAP, SAP, SAP.
SAP. Very good. I am very impressed, Sapna and the other girl, that in spite of you taking some other course, you're doing. See, let me tell you, you can, remove this screen. What happens is, you all know, you are reading in the newspapers that big companies are throwing people out, because there is no business. So mostly what is happening is non-technical jobs are going out. People who are doing MBA or any other kind like accounting, marketing, all those department people are first, asked to go because they're not related, but technical jobs. So I was speaking to some of my daughter's friend who is in IT industry, and they all said that there are a lot of projects which why these companies like Accenture, TCS, Infosys, big companies are even Google, in fact, are actually not terminating, laying off some 2,000, 3,000 employees. Reason being, during Corona time, the IT industries were surviving and they had a lot of projects. Today, as I was telling you in the last session, that most of the company have shifted their business to cloud computing. Shifted in the sense, not shifted or changed their business. They've they have reduced the cost of their IT infrastructure and migrated their data into AWS. So they're giving lot of project to the IT companies for cloud computing. And one of the popular cloud computing platform is AWS. So there's no harm in learning extra skill. Okay, don't think I'm doing SAP or ERP. Okay, SAP and ERP. Okay, fine, you're doing. That is okay. But what is the demand in the market? That also you should know. So that is the reason why I thought I will touch more upon today on one of the application of AWS again. But I'll not be able to show you, but I may give you some exercise to do later, not in this particular month. Next month, I will give you a little advance because by the time most of you might have completed at least 60% of your course. So you know the technology very well and you will be able to solve certain cases. So I'll give you certain cases and you may do that. Today I will start. I have my session divided into two parts. One, I'm going to talk about AI on AWS, artificial intelligence on AWS, how we use it. Second part of it is security in AI, which I wanted to do. And next time onward, maybe I will ask what kind of session you want, and then we'll go ahead with that. Okay. So let's start, students. So first point is the AI in AWS. Let us understand. See, before we understand and learn any technology, it is very important to understand the concept. How does a particular system work? What is the major thing? What is a major concept? What is the process? So here I will be today focusing on a process.
Excuse me, ma'am.
Yeah.
Ma'am, from Hubli KTC shall be present?
Okay. I thought only one team is there. Yes, we can present.
Okay, I'll start.
People who are presenting, please give your introduction also and tell what you are doing.
Good evening, ma'am. Good evening, ma'am.
Good evening, sir.
This is Chandrakant here from Hubli KTC, along with our team members.
Hmm.
So today I'll be presenting on AWS hosting static website through AWS services.
Okay.
To begin with, we need to have an Amazon AWS account. That's as good as creating a Gmail account on Google. So with that, once the account is created, then we need to create a bucket where we store our website details or else any other details on the bucket. So once they are in the bucket of Amazon, then we can host the static website. So to begin with, the bucket which we created is Dharwad bucket. In Dharwad bucket, our website pages are uploaded, ma'am.
Okay.
So these things are different pages of the website. They are uploaded here. About page and picture in the about page that's named as banner here. Then contacts, courses, facilities, faculty, home, QNX website, AWS, this folder. So these are all individual pages, whereas QNX website, AWS, this is the folder. So these all pages uploaded here. Already you have completed the process, but to give a demo of, let's understand how a page uploaded here is given access to the public. So we need to click on about HTML. So here, this is the URL of that page, which we need to paste in the browser. Here we can access the properties of the object, and in permissions, we can see these all things like access control list. This is known as ACL going forward. So these all things are there. Here, object actions. So what actions we are going to perform here? We are giving public access to the public. We are giving access to the public here so that they can access the page. That's here, make ACL. That means make this page accessible to the public, and through this, the page is made public here.
Okay.
Once it's made public, this page will be available to the public, general public, in our website. Otherwise, it will show an error.
Okay.
So the page is given the access. Now go back to, now I have the URL. It's in the properties. So this is the URL of that page. Copy it and paste it to let's paste it on the URL address bar. Okay. The address is here.
Very nice.
So once the address pasted here. So this is the homepage of our website. So we have designed a Kionix website here.
Okay.
This again, we need to repeat the same process for that page also.
Okay.
So this way, by repeating for each and every page, we'll be having giving access to the general public, or else we can do for all the pages simultaneously in one shot, but that's not happening. Individual pages, it's happening, ma'am.
So it will happen when you buy a hosting plan or domain name, and then you use that S3 bucket, and you migrate all these pages to that. Then only it's going to happen.
So this is our presentation about hosting a static website in AWS, ma'am, through AWS.
Any other exercise? I gave a list of exercise.
Yeah, other teams are ready, ma'am, from Oblique ATC. They will be presenting, ma'am. Shankar and team.
Okay, fine. Very nice.
Good morning, good evening, ma'am.
Good evening.
Myself, Samarth, and my partner is Gaurav. He will explain about this host of static web page. It's practical.
Good evening, ma'am.
Yeah, good evening.
My name is Gaurav, ma'am, and we are going to show a demo that how a static web page can be done in AWS by EC2.
Hmm.
In the resource page, we should tap on an instance running, and then we should create a launch instance. In the name page, we have to write our name.
Okay.
And next in application and OS, we should choose AWS Linux as operating system. And in instance type, T.2 micro. And we should create a key pair login. PPK. We should choose as a PPK, ma'am, for use with PPT.
Okay.
In the next, we should choose a creating security group. We should allow all these 3 tab buttons
Okay.
from the internet. Then we should take 30 GB bytes. Is a unit of measure of capacity used to computing. And then we should make a launch instance.
Okay.
It will create a launch instance, ma'am. Then we should click on the ID. Then we should click in instance ID, connect. After clicking connect, we should open a putty desktop.
Okay.
We should download a putty for activate this. Remove. In SSH client, we should tap on it and then we should move to the authentication where it shows a credential. Then in browser, we should tap to the key pair where which we have made it.
Okay.
Then in session, I'll map left side. In sessions, we should copy paste the link, ma'am. We should host a name of IP address, ma'am. Then we should open it. Accept. Now there are some commands, ma'am, which should be run in this virtual instance.
Okay.
Sudo. Yes. Next yum update. Data. Space -1. This command is for to update all the package of instance, ma'am. And next command is for install httpd space minus enter. This command is to install all Apache web server. And next service http space httpd space start. Now we are in a virtual instance, ma'am. Now we can create a file cd space /, where /, www/html vi index.html. Press I to insert. Then paste. We will paste a HTML code, ma'am. Get bootstrap. First get started with bootstrap. Copy. Right click. Then semicolon, escape, semicolon, colon. W for save man, for Q is for quit man. Thanks. Come. IP address. ID. Translate. Copy. This is how we created a static web page.
Okay, very nice. And have you done load balancer?
Yes, ma'am. In another team, they have made.
Okay, thank you.
Thank you.
Good evening, ma'am.
Good evening.
So we are explaining how to host a static web page from GitHub, ma'am.
Okay,
So on first we have to subscribe for Amazon Web Service, ma'am. We have to cover free trial, ma'am, for 12 months. Now we are creating an instance, ma'am. After creating instance, we have already created, ma'am. So we are reviewing this. We will launch instance, ma'am. After launching instance, we will fill this credentials on.
okay,
After filling these credentials, man, we will click. We'll choose the Amazon X1 64-bit into 86. After this, we will instance type. We'll choose T2 micro, ma'am.
okay,
After that, we will select a key pair name. We will create a new key pair. We'll create a new key pair. After creating, we will select the network settings, ma'am. We'll select all the credentials. We'll click launch wizard 10. After storage will select up to 30 GB. As it's free up to 30 GPS, ma'am. After this is a summary, ma'am, what we have selected. After this, we will launch an instance. After launching, we will copy the ID, ma'am. So this will take time to some time. We'll refresh it. Now the instance is running, ma'am. So we will connect it. After connecting, we'll copy that key pair. We'll open Putty, ma'am. In Putty, we'll select the SSH. In SSH, we'll correct authenticator and credentials. After credentials, we'll fill this, ma'am. We'll fill the path, ma'am.
okay,
We'll open the Putty, ma'am. After this is open, we'll go to the session, ma'am. We'll host our IP address in that tab, ma'am.
okay.
Easy to it. Paste. After hosting, we will open it. Now that tab is ready, ma'am. So there are some commands to be done here, ma'am. So by one, we'll put these commands.
Okay.
The first command is sudo super user, ma'am.
Okay.
And the next command is to install yum install git minus y. Minus y. So we'll update this, ma'am. Yum update. Yum update minus y. After this, we will install it on Apache web server.
Okay.
Now we'll start the web server, ma'am.
Okay.
Service HTTP service. On. On. Now the web server is on, ma'am. After that, we will add a static HTML to this, ma'am. Now Shankar will do. So we'll install the GitHub this. The installation is complete, ma'am.
Very nice.
Now we'll log in through GitHub, ma'am.
Okay.
We'll take our center side, ma'am. After we will create a repository, ma'am. Already the repository is created. We'll host it on this. Setting. Maximize. We'll go to settings and we'll open the SSH and GPG keys. We'll create a new SSH key, ma'am. We'll hide the title.
Okay.
Key. We'll copy this. We'll copy this key. We'll go to putty. Again, we'll go to putty. We'll now open putty, ma'am.
Okay.
After opening putty, ma'am, we'll add SSH minus add minus keygen minus keygen minus keygen space minus T space RSA minus space minus capital C. Enter. We'll add a remote centrist email ID. unixx@gmail. unixx public@gmail.com. Now the setup is complete, ma'am. The next step is to eval. Enter. Yes, ma'am. We have got an image for this.
Okay.
ls enter. Again, cat space. Key 2. Yes, ma'am. The route is complete now.
Very nice.
We will copy this key, ma'am. We'll put it in this. Add SSH key. Now the key is created, ma'am. We'll again go to putty, ma'am.
Okay.
Git space. Git add. We'll directly copy it from GitHub. GitHub. ID. Yes. Code. We'll copy this link, ma'am.
Okay.
After copying, we'll paste it in this. Enter. We'll reinstall it. As it is not installed, we'll install it. One Git. Clone. Enter. Yes. Yes. Why yes? Yes. Mhm. Pardon for this. Enter. And this is it. The control. Sorry for this technical glitch, ma'am.
No issues. Doing good.
Enter account. Instance, we'll go to one. EC2 instance. Open this side. EC2. Unix. Down. Copy. Can open address. We'll copy this public IPv for DNS. IPv address.
Okay.
Open a new tab. New tab. Paste the ID. Go. The page is created. Thank you, ma'am.
Good. Okay. So you've shown me a static web page and a load balancing. Any other exercise?
We will show GitHub also, ma'am.
You have shown 3 exercises.
Yes,
too.
ma'am. Yes, ma'am.
Very
Thank you.
nice, very nicely done. You have learned really very well.
Yes.
Any other group is trying to show me anything? I saw in chat box that Haveri
Yes,
and
ma'am.
yeah.
Yes, ma'am. I will be presenting next. I am Viraj Shetty from SSC Averi.
Okay.
Hello.
Yeah, please go ahead.
Yes. Yeah. So, good evening, ma'am. Good evening, everyone. My name is Viraj. So, I'm from SSC Averi. I will be presenting for hosting the web page through S3. So, yes, here is the web page. I will be doing from AWS. So I'm creating a web page through S3 Management Console. So first we have to create a bucket. So put a bucket name of your choice. I will be putting Rengoku bucket. So create a bucket. So I have created a bucket, and here it is. Next, we should upload an HTML file where is the it's an web page. So we should upload it here. So it's here index open. Yes, so I have uploaded the HTML file here. Click on upload. So yeah, I have uploaded it. So next step is go back, go to properties. There's an option called static web hosting. So edit it. So it's disable. Put it enable. After then, type here the HTML file, which is index.html. After that, save changes. And next, so I have saved changes. So next, go to permission. So after going to permission, so edit the public access. So yeah, so it's so grant public access to it. So type confirm so that other members can see your web page. So save the changes. Successfully saved. So go to objects. Click on the HTML file which you have created. Uh, so there is an option called object action, make public. make public. So, grant public access to it. Save the changes. So the object is public now. Go to the object, click here, object action. So it's public. So click on the URL. So which is the web page you have created, click on it. So it's showing error. Sorry, ma'am, it's showing error. So I will check it. I will come back to you. Sorry for it. I will check it. Ma'am.
Okay. Maybe it is some. Okay. Access is denied. Public access is given. Just check that.
Yes, ma'am. I'll check it and I'll get back to you. Ma'am.
Okay, fine.
Sorry for the inconvenience.
No problem. Yeah. Anybody else is there?
Hello, ma'am.
Yeah.
Good evening.
Good evening.
I'm Chaitra from VVS Shapur. I
Okay.
completed my BE degree in civil engineering.
Okay.
So now I will share my screen.
Okay.
So today I am going to explaining about how to host a static website on a Amazon Web Service. So open browser here. Type AWS console login. Click on AWS management. So sign into the console.
Okay.
Here type S3 bucket. S3 means simple storage service which stores the object in it. So click on S3. Now create a bucket. Here we should give a name, that should be a name. We can leave them as default. Click on create bucket.
Okay.
Now it is successfully created a bucket. Now view details. Here we can upload our website. Click on add files. Search index.html. Here now it is coming here. Select the index.html. Upload it. It is uploading here. So now we can check. It is the object URL of our website. It's showing error. So come back to the bucket. We can change some property settings. static website hosting. Edit this. Enable the static website hosting. Then write here index.html. This is an optional. So again, I'm writing HTML. Apply the save changes. Then move on to the permissions. Edit the block public access. Uncheck the box here. Apply the save changes. Then give here name as confirm. Click on the confirm. Now move on to the object ownership. Edit this. Enable the ACLs. Apply the save changes here. So now our objects can be public. Public can access our object. Now we can check whether it is coming or not in object URL. Now it's showing some error again. So go back to the same page. Apply here object actions. Make public using ACL. Then click on make public. So successfully edited the public access, close it. Then we check our website is coming or not. Yeah, it's showing now. This is our website. We hosted successfully on an AWS platform. Thank you, ma'am, giving this opportunity.
Nice. Okay. You have done only one static page, right? The load
Yes,
balance
ma'am.
exercise is not done, right?
Yes, ma'am.
Okay, no issues. Okay. So now, anybody else is there? No. Okay.
Yes.
Yeah. Any other team want to present? Okay, fine. Now, other teams who are left can present in the next session. So today I will be also talking about the two major, thing. One is Amazon SageMaker for AI. Okay, and if I have a time, because it's already 6, then we will also look into, and that also will be your second assignment. Okay, so I'm going to give you 3 assignments in total. First one is done by a few. I have written their names and all who have done. The second assignment also will be given, but I will give you 1 week time to understand and learn that particular assignment, which is very easy for you because some of you were doing really good. And the third one I will tell you once we cover it. So now today we are going to talk about the two components of AWS, which is widely used. One is SageMaker for machine learning, and second one is Amazon Lex for creating bots. That is also very, very important part. And so we are going to go through that. Let me share my presentation. Just give me a second. Okay. So let's start. We will be actually looking into the various application, the popular application. And let's see, because see, last session, you people have learned really well that how to create a static or host a static website. Yes, pages will be running individually. So how to run an entire website by buying a domain name and hosting plan. You can learn that further, okay, and try it on. And the second part was the load balancer. Suppose if there is a huge traffic, how do you equate the traffic into various machines? And how do you balance it so that there is an uninterrupted services? That also one of the center has really done well. So among all the center, I could find that the Hubli KTC center was really very good. Or Vaishali Computer Gallery also good, but then I found the same example repeated. So you can work on that. Then SSC Haveri could not show me, they had certain issues. And I was also feeling that they're not so, they've not grasped the concept very well in the classes. Not I'm talking about my class, because my class or any expert class is not training you on those technology. It's about giving an application and making you do something. And VVS Sahapur also could do little bit on static website, but apart from that, I think they need to work little well. But a round of applause for Hubli KTC. They have really done a wonderful job. So let's go ahead and learn about AI in AWS. So there are a lot of other tools which are there. We are going to learn. So let's understand how AI applications can be built on AWS. What does artificial intelligence mean to the world of Amazon Web Service or cloud computing in general? So, well, AI system, which is also called machine learning and deep learning system, they are the major thing which are basically which the people are using on AWS. So people who are using AWS for AI, they are basically using machine learning and deep learning. Like SageMaker is there. Another thing is also there, but SageMaker is basically widely used for machine learning. So we are going to learn about that in this session. Also, if I have a time, I will show you about Amazon Lex, how to create a bot. And that exercise also I will give you. I will give you a link itself in Amazon because everything is there in the Amazon. Or maybe if I can give you the certain steps I can give you, or maybe a kind of a video you can see and you can try to create a bot, a particular kind of bot. But I want every center to create a bot of different. For example, a particular center can create a bot for pizza ordering, specific bot. A particular center can create a bot for educational center like KionixX. What are the courses offered by KionixX related to that? Okay, so that we will do the project, but don't worry, that project will be only in the month of June, not now. So the ability to think what is occurring within the data, when machine learning is based on that. How do you train a particular model with a training data set? Already we have done with no code AI and understood that. So automation using the machine learning, building certain kinds of artificially intelligent system, that is what we are looking for in AWS. So the idea is that we're looking at two categories of artificially intelligent cloud service on AWS. So one is like, so basically when we talk about that, how do we use AWS? Basically, artificial intelligence in AWS cloud will enable you to make your machine learn through a traditional business processes. And also it will help you in finding a particular kind of a pattern, whether it is a visible pattern or it's a hidden pattern that also can be identified. And also ability to remove some of the human from skill process. That's a basic thing. So when you're talking about Amazon Web Services, as I said that there are two categories of artificially intelligent cloud services on AWS, okay, which is non-native and native. Non-native, which are systems that are used within Amazon Web Services and outside Amazon Web Services. This include like TensorFlow, PyTorch, Apache, MXNet. So we are going to focus on Amazon Web Service native cloud here. Especially that is going to be the Amazon SageMaker, which is something which is widely used by the AI professional who are working with machine learning. So how do you build a power of AI application with the help of AWS? That is something which is done with the help of SageMaker, okay? And that's not also very difficult to understand, okay? So we also know that today, because of the last session, we understood that because of the rise of cloud computing service and also the organization objective to reduce the cost on IT infrastructure. So IT companies are also using AWS platform and giving that platform to their employee to use certain tools available on that because it's very cost effective and everything. So machine learning is also used that. So big and small enterprises are basically tapping into the power of machine learning and artificial intelligence and trying to write certain kinds of business application which will automate certain system. Okay. So when we look into AWS, okay, you have three kinds of learning which can be inbuilt and where you can have an input in the form of data, and then you have a model, and then you have a data. So input will provide a training data to the model. Model will either use supervised learning, unsupervised learning, or reinforced learning to come out with certain kind of output. So supervised learning can be used in certain kinds of cases. For example, you have fraud detection, healthcare, diagnostic. Unsupervised learning like Netflix recommendation system, target marketing, in the Facebook and all social marketing sites. Customer segmentation, how do you do that? Reinforcement learning can be used in robot navigation, gaming AI, and skill acquisition. So again, if we look into certain kinds of data which is used on, or the application which is built using AWS SageMaker, you can find from 2019 to 2022. I've got this data from a particular site, which says that maximum number of organizations are using machine learning feature or tool available, which is SageMaker, on AWS. And the second most learning technology of AI used in AWS is the deep learning. And then the others are also there. Okay. So when we are talking about the data which is available, which can be used, okay. So basically what happens in machine learning, we have already seen in no-code AI when I took a session, that you put a raw data and certain kind of a human learning pattern in the form of model, and the active learning, you train the model using that, and then you automate a process which ultimately, with the help of the training data, it will basically try to imitate the process as how it is done by the human being. So basic steps in doing this is collecting data, the appropriate data, the vast volume of data, and deploying a training model for accurate prediction, and optimizing the model performance by, if you're seeing the model performance, like in the case of dog and mop, you could see that it was not very accurate. So you keep on optimizing the model performance by finding the right kind of input in the form of data, training data, and then deploying the application to production. So this is a basically ML data structure, ML model structure, ML programming, ML application, and ML testing. All these are basically used in SageMaker. So when we are talking about machine learning, ultimately AWS is a public cloud. It has many services which are available for everybody. Okay. So public cloud are not only AWS. There are other companies also who have a big business in cloud computing, like Google, Microsoft, Alibaba, IBM. They also provide a feature of using the machine learning component. And the growth of these tools on the cloud platform is increasing day by day. So there is a huge opportunity lying in the area to learn the machine learning based system on cloud computing system and understand how, for example, if you're using a machine learning for a window based operating system or something, how a single machine learning based system, if learn is not enough, typically multiple machine learning based system is something what is required, and that is what the require, what is a feature or what is the benefit which AWS is giving to all. Okay, a very kind of a different kind of survey was done where they tried to find out that what is a technology which is which can be added to AI to give an added advantage. So when you have a multiple system in AWS or in any cloud computing services which can provide you technology dealing with deep learning, machine learning, AI, IoT based system, certain kind of edge computing system. So that is the growth which is exploding now. And that is the reason why every company, whether IT or non-IT, small or medium enterprises, everybody is focusing on making their employee learn the cloud computing concept. So whatever technology you know, it is not enough. People who have the multi-skill ability are the people who are required now by industry. So if you look at the graph, which is an estimation of the growth of machine learning versus deep learning versus other type of AI, we are ultimately in 2023, but I have a data till 2022. So in 2020, we are getting close to 10 million in sales on these kinds of application. Then it doubled in 2021 and it tripled in 2022. And it is more than that now after the corona. So just for machine learning based system, you can see the growth. And this is the survey done for AWS platform, that how many companies are using the deep learning or machine learning application or machine learning based system of AWS from 2020 to 2022. So ultimately, what this is depicting is that everything we are learning ultimately is going to be employed or used through the cloud computing platform, because the companies are not going to invest a lot in creating a system with that. Forget about IBM, Google and all, but most of the company will be using that. So machine learning as a very strategic advantage for business. And so this is where we are going to learn today. So let us look into some of the used cases. So I want to tell you how basically the machine learning, basically the SageMaker is used in the AWS platform, any platform. So let us start with a simple concept of understanding the machine learning process, how the machine learning process work in any cloud computing platform. The process remains same even in the single system or the multiple system. So here we are going to learn certain cases. I have taken few cases. The first case is the healthcare industry. So we will look at this healthcare industry and we'll what are the kind of input, what kind of model and what kind of output is produced, that we are going to learn in 3-4 examples I have taken. Then I move it to the SageMaker. So what kind of every machine learning, the machine learning process has 3 steps: input, model and output. By now you might have learned all these things. So let us look into the healthcare requirement. What can be a typical input? So input we are going to bring here in the healthcare industry will be the patient's data and the data around the patient. That means like the test, the prescriptions, number of time the patient has come, the heart rate or monitoring blood pressure, all kinds of health parameters which are recorded, all kind of information which is related to current health of the patient, and also any treatment that the patient might have undergone may not be related to the current situation for which the treatment for which these, but the past treatment data. So those treatment that patient have undergone in the past, these two datas are the main input for the system now. Now let us look for the model. For the model, we are going to look at the pattern of success in terms of treatment. Okay, so the pattern of, and also it is very important to learn the pattern of failure in terms of what things are failing. So the ability for the patient to get better or worse with the kind of treatment depends on both the success rate and the failure. Now, what can be the, so we are training the data from the patient data and the treatment data, the number of times the person was treated for whatever illness and whatever is a health parameter data. It allows them to understand that whether a particular test and treatment had a success rate or failure rate. So that is become the training data for the model. So you're training the AI model with that. Let's see what can be the output. Output, we are going to look at the diagnostic, okay, and the likely outcome of the system. So how can we do a better job in diagnosing the patient with the problem that he or she has, and ability to recommend the treatment that increases the success of likely outcome? Because what happens most of the time, if you rely on the patient, information, maybe it may not be accurate. It depends from patient to patient. For example, I was watching a very funny serial, and it was a Kapil Sharma serial and a comedy show where somebody was telling that in a village, when it is a very difficult job for a doctor to understand the patient problem. Because what happens in diagnostic, you go to the doctor and you tell the symptom. And how do you tell the symptom? You understand your symptom in a particular way and you say, okay, doctor, I have a fever, I have this and that and all. Oh, I have a cough, I have a cold, I have a headache, I have, or maybe a pain in the joints, whatever symptoms you tell. From that, the doctor try to diagnose. If he's not able to diagnose, what he does, because that is also again our body, our human mind is also machine learning. The doctor's experience, expert knowledge, his past experience of the similar kind of symptom make him understand that maybe this is a problem. And if he's not able to understand, what he does, he asks you to do certain tests to confirm that. That's the diagnostic part. So in that particular funny comedy serial, it says that when a villager goes to a particular doctor, he can't describe the problem very accurately. The symptom, he tells that, okay, fine, I have got, this kind. He make a sound and say, this kind of sound, my head is, it feels like somebody hammering nail, or it is doing tick tick in my head. All those kinds of things they tell. And the doctor need to make an understanding from that. Okay, so the kind of data, information which the patient give, that is not enough for a particular doctor to diagnose. So he require the personal history of the customer, or maybe if the same patient is coming day and every day to him, every time to him, may understand that the patient basically doesn't know properly. This is how we should ask question. So the doctor trained his mind with the previous data, the information, the way the information was provided, and how accurately the doctor was able to diagnose the disease. Similar way, we adopt the same model in the machine. The only difference is the machine is little faster to understand a pattern, and with all kind of data, not only the patient information, but the diagnostic or the test data, the previous treatment, whether it was success or failure, will help the particular system to analyze and diagnose a disease. Okay. So the solution look like this, if we do this input and model and output, then the solution, we have now data that is ingested, which is the patient data, the past data, typically from the patient data, from the clinical system, Maybe sometime nowadays it is very, very important to know that most of the patient comes with some data on their own. Like if they are wearing iWatch or Fitbit, they'll come and tell my heart rate is increasing. And they record in that those wearable devices and show that. So that data also can be considered. So it's any kind of data is good. So the ability to leverage an unsupervised machine learning here. We can't use a supervised machine learning. We have to use unsupervised machine learning here. And the ability to to use this massive amount of data and identify a pattern about them. That ability to automate the use of, and so this ability is built with these kinds of data to automate the use of information, process that information, and help in diagnostic. So converting action to outcomes. The ability to look at, for example, what is succeeding, what is not. And make sure that we follow a pattern of success, not follow the pattern of failure. So from the past data, we train the model that these are the things which are done has failed. And these are the things when it is done, it is passed. Has a success rate. So that is how the ability to communicate back into the machine learning, communicate back out to the clinical application system interface, which is receiving the data in the form of information that is coming as a training data for machine learning system. So that becomes a loophole. So what happens if the data outcome is a failure and result is failure, if it is predicted that these data, if it is used, the model will go back and give that feedback. So that is how the communication or loopback or feedback is essential here. So now they can get so this is a clinical application interface with work with this, and the results are early detection. Sometimes what happens, the results come in the form of early detection. So we will be able to accelerate the amount of time it takes to find health issue within people, because sometimes it happens that there is a serious illness and the diagnostic take too long. And the treatment, by the time the treatment starts, the condition become worse. And by looking at a lot of information, understanding how that information exists in relationship with the other information, that's where the machine learning helps. So for example, 10 of thousands of other patients that have. So what machine learning will do is not only they will take an individual patient data as a training data, they may take the other patient data also, the 1,000 and other patient data who have suffered from the same disease and had the same kind of symptoms or characteristics are also used to predict or do diagnostic. So outcome-based learning going on, ongoing it will happen with amount of data from the other patient with the similar kind of symptoms or similar test which has happened, whether it was success or failure, that also comes as an outcome. So it will learn the ability to consider the success or failure, the ability to look at what is working, what is not, and the ability to adjust your training data and the knowledge base in terms of what is desirable outcome. So in which ultimately what happens as a result, when this particular case was adopted in AWS, I've taken all these from AWS website. There's nothing new. So these all diagrams are there. I just copied and I'm explaining you. So the result of this was when they did this in healthcare, some application was built. There was 40% increase in the correct diagnostic and saving people and surviving them. So the real world situation where we are going to leverage machine learning will help in doing a proper diagnostic, increase the chances of success for that, and help in providing a better healthcare to the people. So that is what is one case. Let's look in the finance industry and take that case. Again, we have 3: input, model, and output. Okay. So input is going to be what? The input here is going to be a transactional data and a fraudulent data. So any kind of a transactional data, which is day-to-day transaction, maybe in a bank or any finance company, and the fraudulent data, which are fraud, which cause frauds. That is also necessary. So both kind of data set you have put, two categories of data, transaction data and fraud data. And the ability to look at the massive amount of transaction data that occur in daily processing. Maybe for a bank, let's say, ability to look at the aspect of which, ability to understand the characteristic of our fraudulent data, which type of data can characterize that particular transaction as fraudulent. So the model will be looking at the pattern of the fraud. Which kind of a data, if you observe, what is a pattern which can identify the fraudulent transaction? And the output will be ultimately detection of fraud and ability. Now, it is not enough that you detect. There is an ability that the machine should prevent that. Early detection and preventing that. So that's a proactive solution, not reactive. Reactive, once a fraudulent has happened, then you do whatever. The loss has already happened. You lose the customer. So before, proactive means you are detecting and helping in preventing these kinds of things, like any kind of a fraud. So solution is what? How do you provide the solution? The solution again is going to be, in this case, we are going to use unsupervised learning based system. Because we are dealing with massive amount of information that typically aren't tagged as fraudulent and unfraudulent. It is the ability of the model to identify a pattern which can characterize a fraudulent data with the information and ability to leverage the automation. Now, to leverage that data into proactive and useful way, ultimately it should have an ability to look at the outcome of those situations which are going to help them in identifying the fraudulent problem and solve the fraudulent problem, both in proactive way and also in reactive. Sometimes it may happen the fraudulent already occurred, but you're not able to identify that. So that's called reactive way. So proactive is before it happens, you identify and you prevent it. So this is the thing. And the result ultimately lead the ability to detect the fraud in react and, as I said, proactive way. So we are dealing with an outcome. So what happens? What is the result? This is a solution. What is the result now? The result is the ability to detect the fraud in both. If it has happened, it is reactive. If it has not happened, proactive way. So we know how to spot typically before it is going to happen or it has already happened, a fraudulent transaction. Ultimately, we are dealing with something in the machine learning, which is called outcome-based learning. And it has to be outgoing. There should be always a feedback to the system. If it is normally unsupervised, feedback helps in learning, making the machine learn. So we are leading into the result. And this is a real case, which was used in AWS. 60% of transactions which result in the fraud are now reduced. It are detected proactively and it was prevented. And it also helped the bank and the financial institution to avoid certain kind of governance or security measures. Let's look into manufacturing. So if we look at machine learning based application for manufacturing, we again have input model and output. In this case, the input would be a factory data, which can be a raw material used, wastage, labor time, machine time, what is the production volume, all those kinds, right? And this information will come from the factory in terms of production, if it is a robot who's doing or building a product. So that also information automatically is generated and come as an input. Also, the ability to have a reject data. Reject data is the ability to figure out where there is a quality issue, which causes the product to be rejected, right? Sometimes you, for example, if it's a biscuit factory, right? And you're making a biscuit which is rectangular in shape. Sometimes the biscuit doesn't come in a rectangular shape. So the biscuit tastes same, quality is same, but the shape is triangle, let's say. So it is rejected. So those are the quality, either it is rejected by the quality inspector manually, or sometimes it happens that automatically it is rejected by machine as a system or customer themselves. So we are looking at a factory behavior as a model, how the factory is behaving ultimately in tracking that pattern to find out rejections. So, and the output could be reject prevention, less number of rejection, that means the faulty output, and ability to increase the quality control and quality in production. So it is a proactive, it can be a proactive training and maintenance, the ability to change the thing so that rejection which happens will reduce and the factory will not lose money on that, because anything is which is rejected is non-productive. It is like you are not able to use that and you can't reuse to make the product again. Like biscuit, you can't make it dough again and you can't produce the quality or whatever I'm saying, the proper thing. So whatever it is rejected is rejected. It is a loss of money for them. What's the solution? So the solution again is the data, which is coming from factory. It is ingested from the factory. And here in this case, the model or the method we use is reinforcement learning. We are automating the various systems so that we are feeding this back directly to where they can be most effective. So in other words, if it is on a line manager, they understand where the rejects are occurring and where the quality issues are occurring, perhaps down to a person, to a machine or to a robot, whoever is doing the production, the ability to change those things. So it helps the line manager to identify how the rejection will happen. That is a proactive method. And in which phase? Suppose if it is what you call the process, then in that assembling line, then in that case, they will understand from the first point, second point, third point, where the major issue is happening, and they may try to change that, whether the labor is doing the manufacturing or it is a kind of a robot doing the manufacturing. Okay. So ability to identify the reject and identify the pattern of reject. Then finally, the ability to externalize this through manufacturing application. You build an application in which you feed all these data and train the data to understand, which can be used. So now, for example, a factory manager may carry around mobile device. They can be alerted as to when the machine learning based system is finding a reject and a pattern that are leading up to reject, and proactively allowing the manager to stop that rejection, to prevent that rejections. So now we notice that we are using a reinforcement learning here. We are not using supervised and unsupervised learning. The reason is because if we are going to figure out what is causing the reject, we are going to be feeding that information back into the system. That is called a supervised learning. We know, okay, this thing happens because of that rejection happened. So that's a supervised. In other words, if we are producing a product and that product is ultimately going to be reject, then we are telling the machine learning based system that this is what a reject is, what lead up to reject. And then it is learning by having the information put back into it. So what happens in the reinforcement learning, by trial and error method, whatever rejection, new, innovative, novel method comes, that is fed back into the system to train the model. And through that, it will learn just like a human being and able to identify the reject origin. In other words, we know that what is causing the reject to occur in terms of machine or maybe in terms of individual, or by identifying a pattern. Okay. So this is how again, if we look into the solution, so basically we want to identify the reject origin, what is the cause and what is a pattern through which we can identify that if this is a particular kind of a pattern, this kind of raw material, this machine, or these many time, or these many system, or this the process, then there is a rejection and all. Ultimately, it will look into outcome-based learning, because any kind of a feedback which goes back as a loop feedback to the system, and it make the system learn from that if this happens, the rejection happens. If new system, new process is happening, because of that, the rejection is happening, again, that feedback goes. And this is how the reinforcement learning happens. So the correct information that keeps out of it and keep on reflowing back into the machine learning system will make the machine smarter and will adjust the application, manufacturing application, on the base of the new knowledge which is created and the existing knowledge base. So in this case, there was a 75% of reduction in rejection and return. So it's a very successful outcome. Let's look into the one more system, which is called education. So when we look into the education case for machine learning, we have again input, model, and output. In this case, input will be student information about student and their grade. And it may have many relationship, one students for many grade that we are tracking, many subjects they are learning, many semester. And the ability to model student performance, that is a model. And the output would be the failure prevention, number of the success rate for the student, and ability to look at the way in which we are going to improve the failure rate and dropout rate or flunk out rate. So proactively, machine learning will prevent that number of people, suppose 60, your result is 64%. That means what? That there are, 36% of people who are failing. How do you reduce that? You can't make it 100%, at least you can reduce by 10%. So that what is the solution for this? So this is the model. The solution is, again, we are taking those data of student performance grading of last semester, and we're using the type of machine learning, which is known as here supervised, because we have a structured way to find out. We know how to do it. We don't want to do a trial and error method. The ability, we can have a tracked information which can be tagged. We will have a tracked variables like grades, attendance, behavior, many things, right? So we know the grade that student have received. That is a very structured way, information and correct, accurate data we have. There is no possibility of any other grade, can be only one. We're not tracking here the massive amount of information. We have to deal with cluster. Where we have to deal with cluster, here we are leveraging unsupervised, where we see massive amount of data, we will be using unsupervised learning. But if we are dealing with a known data, which is fairly well structured, and we know the pattern, how to find out the failure rate while dealing with this, so that time we will use a supervised learning. Okay, and we will automate all these information and feed all the data into the system, so we can take a proactive and immediate action on the student who are getting off the track. Because with the automation, with the grade and all those kinds of pattern, we will find that which is a pattern which will make a student fail in exam and not being successful. So the ability to understand the pattern of the failure that leads student to drop out, what leads student to flunk out, and the ability to link all these information to the admission and notification to the professor. So they're able to engage early in getting troubled student back on the track. How, so in other words, increasing the graduation rate, increasing the effectiveness of education system. So what is the result of this? The results are proactive students management. The ability to leverage machine learning to figure out when a student is likely to get in trouble or fail in the subject before they get in trouble. So the ability to look at variables, like as I said, there can be a lot of variables which are fixed structured data, like attendance. If the student's attendance is, let's say, around 30-40%, maybe the student's not coming regularly, there is always a possibility those students will fail. And also the past internal assessment data, the last semester data. So you look at that, and sometimes there are other data also which help. You have another variable which is indirect called financial issues. The ability to look at that variable of the grade pattern are now combined with financial issues also to find out whether a student can improve their capability to learn, improve their study habit. Because sometimes what happens, the student will have that certain kind of a personal issues, anxiety problem. They may be very good students, but they are attending also well. Their grades in the last semester is also, there is some personal issues in the house. Because of that, there is a stress. So that also has to be added. Okay. So that may cause a particular student to fail in certain semester. So the last previous data pattern tell that, okay, fine, the student is good, he may succeed. But suddenly there is a drop in the grading. So there we can use outcome-based learning, where we can also understand similar kind of a pattern or data, habit in other students who were good, and suddenly their performance started dropping because there can be several reasons for that, maybe personal, financial, so many, okay, bullying or whatever issues. So what is a various kinds of variable which can cause a particular student to pass and fail, that has to be fed. And when this intervention is done personally, it can be done through machine because we're human being. Sometimes it may happen that I'm also a teacher, and sometimes it may happen that when you understand that a particular good student is dropping in his success rate, is not paying attention, his attendance is dropping, or maybe he's coming but he is not interacting in the class, not, then there is a kind of a our machine learning in our brain as a teacher may start asking question to us, why this particular person is suddenly doing this. There can be some kind of a stress, and maybe most of the time the student is not ready to give that information. So how do we help that particular student to come out of that mental stress, come out of that anxiety, come out of that particular emotional issues, and increase the success rate? It should not affect their performance. So ultimately, the results were good when these systems were used. 15% reduction in the student leaving the university and academic. And there was, so the effectiveness was very good when they did it. So we're going to talk about SageMaker. Let me see the time. Okay, we have time. So Amazon Web Service SageMaker, there are three major functions. It allows you to build the model. It allows you to train the model. It allows you to deploy the model. So there are 3 steps in doing that: build, train, and deploy. Okay. I will not be able to teach you this, but then I will give you a little bit idea about that, because these are very easy if you understand the concept. So and it also have the ability. So the 3-step process: build the data, train the model, and deploy using some kind of a algorithm. So what happens? It uses the algorithm, the ability to really also leverage some kind of a framework. Framework is a process which is pre-existing. And once you have built, you have the ability to leverage a container. So we have to also understand that you have to tune the model. Very important. If you remember the OpenAI session, their no code AI session, where we learn about how you can tune the model with a perfect data set, or maybe the perfect way of modeling the data, modeling the AI. So building the model. So that's a capability of SageMaker. It's not about building the model and training the model with a training data, a solid training data or massive amount of data, but it is the ability to tune the model to make sure it is meeting the need, it is able to take on knowledge characteristic that you're looking for, and we are able to use SageMaker collect data. So training data is very important because, again, it is garbage in and garbage out. That means that a massive amount of data will be fed into the system. But if you build and train which are the data which is not garbage and which is garbage, it will filter out those kind of data. So your ability to train a machine learning based knowledge system is your ability to feed the data. So if whatever system you are using, we need to choose the correct algorithm. We have to make sure we choose it wisely, because it is going to determine the way your model behave. We all have heard about the algorithm and we are ability to determine a pattern within the information that we have already spoken about. So we're able to set up an environment which can be trained. So what happens here is the steps for doing and tuning and training the model basically start with your collecting and preparing the training data. and then choosing a optimized ML machine learning algorithm. And then set up an environment, train, tune the model, deploy the model, scale and manage the production system. So when you are going to load a tremendous amount of data, which is a training data, it's interacting with something. We are able to push the model into production. Model need to run on some state of some kind of a platform. Okay. You need to have a storage, you need to have a CPU. So you need to also select a proper machine to do that. Either you use a virtual machine on the AWS or you use your own machine, but it need to have that capability. So we need to understand in the SageMaker build that we are dealing with a pre-built notebook. Okay, that are basically this pre-built notebook. These are certain features which can use in the SageMaker that is basically allowing us to use things that are already pre-baked for us. There are certain things which are already done. We are using these templates, which makes our job very easy. So you're not starting from a scratch every time. And whatever templates you're making, like how you have shown me today, you can save it as an instance. Again, here also we use instances. So when we use SageMaker for the first time, your ability to pick the right template and leverage it correctly will be the largest learning point for you to determine your success rate of your machine learning project. So we are able to use built-in useful algorithm. They are able to, which are able to provide different kinds of framework. Like it is integrated with Jupyter Notebook and allowing the developer to look at the database data set directly. So there are many choices of algorithm that are pre-built within the SageMaker. We have algorithms such as forecasting. We have algorithm like the forecasting, supervised learning, unsupervised learning algorithm, the ability to deal with image and object classification, and then neural topic model, sequence to sequence. So basically, most of our machine learning needs are going to have algorithms that are available with SageMaker. These are pre-built for you. So you can create your own algorithm that SageMaker is not stopping you. But SageMaker has some kind of pre-built algorithm also, which make your job little easy. Okay. Now, let's see what's the time. So what I'm going to do is I'm going to show you a video on this, or maybe let's see if I can show you how it works. Okay, so how do you create a SageMaker? So when you go to the AWS console, you can just go to AWS, and in the you have to find out the SageMaker over here. And I'm just showing you the screenshot because I don't have my active account on the AWS. So you can see here. So under the machine learning, you will find the SageMaker. You can go ahead and click on that. Now you know that it gives you a different way to do things. You have something in SageMaker called ground truth, which has the ability to build and leverage the notebook, which I told you, and to train the model. So you can create the model from the training job, or you can import also the external model. That also is possible. So if you see here, these are the things which are there: ground truth, notebook, training, and inference. So notebook, you can create the instances and you can save those kinds of instances over there. And you can look into your recent activities, and which will appear as a learning content or feature spotlight. So the first thing we are going to do is to create a notebook instance. And we can go to the notebook instance here. Okay, you can see here. And if you want, you can just search for existing instance, which are going to have get stored whenever you're creating. So we're going to create a new one. So what we are going to do is, in this thing, when you click on create notebook instance, you get this page. You have to give a name. Okay. And whatever name you want, let's say demo 1 or whatever name you want, you can give the name, maximum of 63 alphanumeric characters. And then you can include also hyphen. It will be given some kind of a logic and some kind of a formatting for that. It can be unique within your account. or AWS region, now you have to pick up a notebook instance. And having done this a few times, you may also going to pick up something called extra large cost some reasons in this. Okay. So we keep on filling this, like we fill something medium instances here. In this, we are filling the medium instances. There are drop here. You just have to click on whatever is your need, and then you can choose some kind of a elastic inference. You can choose extra large. You can go ahead and do that. Then there is also additional configuration like lifecycle configuration, which is optional. You have to create those kinds of a volume. Then you have permission and encryptions. So permission and encryption is a identity and access management role. Okay. So basically you can, it can provide you the ability to create a new role, use an existing role if you've already created. So if you created a role before, then you can go ahead with that. Otherwise, you can have an access optional. You can go and give a user root access to the notebook. This is just a demo. So encryption key, if you require, that is also optional. You can actually enter an encryption key and to secure your data. And we have a virtual private cloud platform, which is also there. You can see here. Okay. So virtual private cloud, your notebook instance will be provided with a SageMaker to provide access to VPC, the virtual private cloud. That's an optional thing. Okay. You can choose that. You can also leverage your Git your repository. Okay. If you need, you can do that. Key and value pair, fill the system. So I'm now going to go ahead and click, when you click on now, after that, this create notebook instant after filling all these necessary, optional you can leave. And you need to understand all these terms. I'm just showing you how it works. And your notebook instance is created. You can open the notebook instance when the status is in service. Okay. And open the template notebook to get started, and notice is going to be pending because it takes 5 minutes or 10 minutes before it go on the AWS infrastructure and allocate everything back to it. Now you can feed the data and you can do all those kinds of things. So basically you have just created a notebook instance, and after this you have to create a lot of other things for it. Okay. So I will just show you a video on this. Just give me a few seconds.
Amazon SageMaker helps data scientists and developers to prepare data and build, train, and deploy machine learning models quickly by bringing together purpose-built capabilities. These capabilities allow you to build highly accurate models that improve over time without all the undifferentiated heavy lifting of management. And developers to prepare data and build, train, and deploy machine learning models quickly by bringing together purpose-built capabilities. These capabilities allow you to build highly accurate models that improve over time without all the undifferentiated heavy lifting of managing ML environments and infrastructure. Let's see how SageMaker helps you develop great machine learning models by way of an example where we build a model that creates a musical playlist curated to the listener's taste. First, you need lots of data. SageMaker lets you connect and load your data from sources such as Amazon S3 and Amazon Redshift in just a few clicks from SageMaker Studio. You can use this data to train your model. Models learn complex and subtle patterns to let you map inputs to predicted outputs. So you'll need a large quantity of metadata about songs, such as length, beats per minute, genre, and rating. Next, you'll need a strong set of features. Data in its raw form usually doesn't provide enough or optimal information to train a model. And so, to maximize the signal and reduce the noise in the data, you need to convert and transform it into features through a process known as feature engineering. For instance, beat and genre could be combined into a feature called danceability. Creating features can take over 80% of model development time. Instead, you can use SageMaker Data Wrangler to convert, transform, or combine raw tabular data into features in a fraction of the time it typically takes. With a single click, you can save these features to SageMaker Feature Store, which lets you check in and check out features. The service lets you create multiple versions of features, and you can add descriptions and search for features, which helps your teams understand and use them for other models. You can retrieve an entire dataset for training. Once your model is deployed, you can retrieve individual features to make low latency predictions, such as predicting in real time that the user wants to listen to more songs with danceability, like ABBA's Dancing Queen. Next, great models can be used in different situations if they are trained on a balanced set of features and data. You use SageMaker Clarify to help ensure that training data is well balanced, which means that the possible values for the features are well represented in the data, and that the accuracy of the trained model is roughly the same across different subsets of the data, such as different musical genres. For example, if you had a preponderance of blues music in your training set, the model would probably create a lot of blues playlists. That's fine if all you do is listen to the blues, but your model will be even more accurate if you use an evenly balanced set of features representing dozens of different genres for training. So you can use SageMaker Clarify to identify potential bias in your training data. This will help you ensure your model is trained across a range of musical genres, leading to more accurate predictions. You can also use SageMaker Clarify to inspect individual predictions to understand how each feature plays a role in the prediction. This allows you to check that the model isn't overly reliant on features that are underrepresented in the data. One of the great things about machine learning is that models can improve over time, not just based on new data as it becomes available, but also by incorporating the learnings from tools like SageMaker Clarify and SageMaker Debugger to systematically identify sources of error or slowness and remove them from your model. With this approach, you can condense hundreds of thousands of hours of real-world experience into just a few retraining iterations, so your models can improve quickly. And since you want to continually improve the model by rebuilding it regularly, you can take advantage of Amazon SageMaker pipelines, which provides continuous integration, continuous deployment capability to automate the entire machine learning development process and replay it with a single click. This decreases the time between model improvements and delivers better models more quickly. Amazon SageMaker provides tools which every developer is familiar with: visual editors, debuggers, profilers, and CI/CD, all wrapped into an integrated development environment for machine learning. Get started right away with your machine learning project from SageMaker Studio.
Okay, so we can end the session over here. Most probably in the next session, we will have the rest of the team presenting. And also I will tell you about how to create bot with Amazon Lex, and we will take the exercises. I'll give you on that, and AI in security. And then we will see that. Okay. Okay.
Okay, madam.
Thank you.
Okay, then bye.